Hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, construct tree from in-order and pre-order. Okay. So what the problem is saying is we'll be given two arrays, in-order and pre-order traversals, okay, of a binary tree. And from these two arrays, we want to generate a binary tree and we want to return the head of the binary tree. Okay. This is the ask. Okay. Now what are these? What are these two arrays? They are the in-order and pre-order traversals of a given binary tree. Okay. Now, first let's see what are pre-order and in-order traversals. Okay, so let's say this is the given binary tree. So what will be the pre-order traversal of this particular binary tree? So you know the pre-order traversal is root, left, and right. So for example, if we start from the root node, okay, for the pre-order traversal, what will be the order? 0, right? 0, then we go to the left, 1, we go to the left, 3, then we are done processing the left child, then we process the right child, right? And then we are done processing the left subtree of 0. Now we go to the right subtree of 0, then okay, there's no left here, so we'll print 5. So this is the we'll print 5. This is a pre-order traversal, okay, of a binary tree, which is you can see here, right? And what is the in-order traversal? In-order traversal is left, root, and right. Left, root, and then right, right? So so for example, what will be the in-order traversal? So here, if we start from here, right? So we're going to go first to the extreme left, right? Extreme left. Okay. Once there's no left child, then we are going to print this particular element 3. Okay. Then we are going to go back. We're going to print 1. Then we are going to go to the right. We're going to print 4. Okay. We are done processing. We'll go here. Left is processed. The left subtree of 0 is processed. Now it will be root, right? And then we'll go to the right and we'll go keep on going to the left. So there's no left child of 2. So it is going to be 2 now. Okay. Then 5. Right? So yes. So this is the in-order traversal of a binary tree. Okay. So yes. So I think you've got the basic now. Now let's quickly see how can we code. Okay. Okay. Now if you observe, let's quickly observe the arrays, right? Let me write here the arrays, right? 3, 1, 4, 0, 2, and 5. Okay, this is the in order traversal and pre-order. Let me write here. It is 0, 1, 3, 4, 2, and 5. So if you closely see, there's some pattern. Okay, there's some pattern here. So what we're going to do here, we're going to first take, since you know, the first element will be the root element, root node for pre-order traversal. So we're going to take this element. Okay, we're going to take this element. And if you see, if you search this element in the in-order traversal, it mostly will be almost at the middle of the in-order traversal node. So if you see 0 is at this particular position, which is you can say almost middle of the in-order array. Okay. Now, so wherever is this 0, right? So on the left side, whatever are the elements, they will definitely come on the in the left subtree of 0, in the left subtree of 0. And the on the right side elements, they will come on the right subtree of 0. For example, it will be something like this. 0 is the node, right? 0 is the node. Then it will look something like this. 3, 1, 4. And this particular 2 and 5. It will be like this. Okay. So what we are going to do, we are going to pick up the root element. We are going to search the position of this root element in this pre-order in the in-order traversal. Okay. And we will pass these elements recursively for the left sub for this recursively, these two parts, right? Recursively. Okay. Then once, for example, now we process this, we have this in the array, right? We have this in the array now. So what are we going to do? Now we're going to search for the next element of the pre-order traversal, which is 1, and we are going to search in this in order. For example, here is the in order, right? In order, right? We're going to search. We are going to take this next element of pre-order. We are going to search in this particular array, right? And if you see, it is right in the middle. It is right in the middle. Then again, we are going to take this recursively, these two parts, the left and right parts, and we're going to pass on recursively, and so on. We are going to solve this using this. So I hope you have got the intuition. I think you'll understand better with the code. Just be with me, you'll understand better. So before going to the code, I'll just request you please subscribe to the channel, like the video. So first we will implement the code in Java followed by C++. Okay. So let's have the some variables in which will be in start will be 0 and in end will be uh, in order dot length -1. Okay, these are the start and end indices of the in order traversal. Now we are going to take index of pre-order, right? We want to take index of pre-order. So we are going to, why we are taking this array, I'll explain this, because we want to modify, right? We want to modify this pre-index in the given in the function. Okay. And if you take directly in, then it won't retain the value because of pass by value property, right? In Java. So pre-idx of 0, let's initialize with 0. Now what we're going to do, we're going to call a util function. Okay. Then we're going to pass in order, pre-order. Okay. In start, in end, and this pre-index. Now we want to do one more thing. Okay, what we're going to do, we're going to create a hash map. I'll explain. You'll understand why you're using hash map. Integer, comma, integer. Let's call it in map. A new hash map. Okay. Now what we're going to do, we are going to iterate in, let's say, in element, in element. No, we want the index as well, I less than in end plus plus I. So what we're doing here is, what we're going to do here is, we're going to ingest the the in order the in order element and its position. I'll explain why we are doing this. So what we are doing, we are creating a hash map with the in order element and its position in the, so for example, if here is the 3 1 4 0 2 and 5. So here is our array, right? Here is our in order array, right? So what will be the map here? Key and value. 3 will be the key, 0 will be the index, 1 will be the key, 1 will be the index, 4 will be the key, 2, and so on. 0, 3, 2, 4, 5, and 5. How the map will look like. Okay. So what are we going to do? We are going to pass this map instead of this in order. We don't require this anymore. You'll understand why. Now what we're going to do is uh, static node util. Let me write this map, then int pre-order, int in start, int in end, pre-idx. Okay. So this is our util definition. Now now first of all, let's see what will be the base cases, right? Let's add the base cases. If in start becomes greater than in end, right? Then definitely like we need to break up because in start should be less than in end, right? Or pre-order, pre-index, right? Pre-index of 0 if it has become greater than pre-order of length, right? That is the index is greater, become greater than or equal to length, then we want to return, right? These are the base conditions. We want to return from here. Okay. Now let's write the main business logic. Now what we're going to do is let's have, as I said, right? Let's have root value. Okay. From the pre-order, which will be pre-idx of 0, pre-index of 0. Now, what we are doing here is what is root value? For example, let's quickly go here. So if this is our uh, pre-order in array, right? Pre-order array, right? So we are taking this root value, right? Root value. Inside root value, we are taking 0. Inside root value, we are taking 0. Now we are going to find this root value in our in order map. Okay. In map dot get. Definitely you will find this root value. No doubt about it. So this will give us our root index in the in order array. So you're getting my point, right? So here what we did, we took this zero, we found this zero in this map, okay, and we had this root index. So we fetched this root index, which is three, which is what? This is the position. This three is a position in the in order array. This 3 is a position of this particular root, of this 0, of this particular root in the array. If you see 0, 1, 2, and 3, right? 3 here if you see, right? So we took this. Now what we're going to do here is we'll also create a root, right? As we want to build a binary tree, right? With this root value. So what we did? So we are building root. What is root value? So here is a node, right? And what is the root value? Root value 0, right? Root value 0. Root value 0. Okay. Now, what we're doing, we will now we'll have recursive calls now. Root dot left, right? Root dot left, we'll call util. Then we'll pass this in map, and then pre-order array, right? In start will be as is. Now, what will change here? Root idx -1 will pass. I'll explain this. And we also want to, as since we want to go to the next element, right, of the pre-order, right? So we want to increment 0 plus plus. Okay. Because the next time, for example, now I'll explain what we are doing here. Okay. So pre-index, we are passing here. And let me write this as well, root dot write. Root dot write. Then this root idx will be +1 and in end. Okay. Okay. Now what we are doing here is, if you see, right? So what we did here is our in order array, right? Here is a root idx, right? That's what we are saying, root idx. This is a root idx, right? Root idx. What we are doing now is we are passing these elements, right? These elements, the left part. If you see, from in start is here, in start is here, and in end is here. So now, so what we're doing, till root index -1, that is till this element from instart to, we are passing now recursively these two parts. Which part? This is first part, and second part is this one. These two parts we are passing now recursively, if you see, right? In start, these will be, what we are saying here is, these will be, for example, if you see, now what is root? Root is this root node, right? Now what we are saying is root dot left. Root dot left, we are passing the elements from in start to root index -1. Root dot left equal to elements from in start from root index -1. So which is this 3, 1, and 4. Okay. And root dot right, right? Root dot right. What we are saying, root dot right, root index +1 till in end. Root index +1. What is root? Root index is here. Root index +1 is this. So 2, 5 we are passing. Okay. I hope you're getting, and this will call recursively from this left subtree again will form a node, which will be most probability is going to be 1, and this will be the left and right subtrees, right? So in this way, we are building the binary tree. I hope you're getting. So finally, at the end, what we are going to do, we are going to return the root. Okay, we are going to return the root. Okay, and here this util will return the root of the node. Okay, let's compile this. Let's see if it is working. May have some compile errors, not sure. Okay, no compile time error. List. What is the output here? It's taking long time. Let me refresh this. Okay, let me compile again. Oh, we have found some null pointer exception at 90. 90. Okay, why is that? Let me check. So the issue here is I took in end, right? Which is again it will go till last element. It will ingest the elements till the second last element only. So I need to go till in order dot length. My bad. So let me compile this again. I think this should be working now. Okay, let's submit this. Okay, thanks for watching. I think the test cases are being processed. Please don't forget to subscribe to channel, like the video. Let's quickly see the C++ code as well. Here's the C++ code. So, so what we're doing here is we are taking unordered map. We are filling the unordered map with the element and its position. We are taking in pre-index here, and then we are passing by reference this pre-index. And okay, here the base condition is in start greater than in end. This should be sufficient. This should suffice. And then what we're doing here, taking the root value, right? We're taking the root value, we are building the root node out of this root value. Then we are searching this root value and fetching the index from the map, right? And then we are going recursively from for the left subtree. We are starting from the start to root index minus one. From the right sub for the right subtree, we are starting from root index plus one till in end. Okay. And finally, we are returning the root. Okay. So this is a solution. I'll also attach the code in the description section. Thanks for watching. Please subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.